Alright everyone, welcome to chapter 5. This one looks a little different than the way we normally do videos because I'm going to try to go back and forth between the Linux VM and the PowerPoint here. So, um, something that we haven't really talked about yet is kind of how data gets in and out of Linux. So, anytime you have anything that shows up as uh, a, what Linux refers to as a device. And this can be a keyboard, this could be a mouse, this could be a digital camera, this could be a CD-ROM drive, anything like that. Linux is going to see that as what it calls a device. And a device in Linux is going to actually show up as a file that you can put information into or get information out of. Now, that may seem strange, but the way Linux is has been designed from the ground up to operate is that everything is going to be a file. So if you attach a new, say, a keyboard to your Linux machine, well, that keyboard is a device that Linux is going to read data out of as you type it in, right? Well, that's sort of like a file if you think about it. And if you attach, say, a hard drive to it that you're just going to write backup files to, for example, well, that's a file too. It's just a file that we're writing data to. And one of the things we already talked about in this class is how to read or write data from a text file. And when the way the Linux file system is designed is it generally is going to think about any operation that it does that involves a data transfer as reading to a file or writing to a file. And those files happen to be just text files on the system, then we're familiar with that. For writing to a device that is a file, the type of file that describes is not surprisingly called a device file. So what we're going to talk about in this chapter is taking a look at device files and figuring out how to get those into our file system in some way. So that should blow through the first couple things here. One of the things that I want you guys to see here, though, is that most of those files, in fact, pretty much all of those files, are going to be located in the dev directory. And so what we should be able to do here is, well, is cd into dev, and I'm actually already there, but if you want to do this on your Linux box and then do an ls, you should be able to see that there's a whole bunch of stuff here. All right. Now, not everything in here is a device file, but a whole lot of things are. Some of these are things that you can probably guess what they are. Some of them are going to be a little bit less obvious. For example, CD-ROM, I'm guessing, well, I'm not really guessing because it always is like this, should point to the CD-ROM, right? Well, I mean, that should be a file for the CD-ROM. But if you look at the color that CD-ROM shows up there, that's actually a shortcut. So if I did ls-l CD-ROM, what that's going to tell me is that CD-ROM is a soft link that's actually pointing to SR0, which is the more traditional term for the device file that winds up pointing to the CD-ROM or the DVD drive, or kind of the first optical drive in the system. Now, that CD-ROM link doesn't have to be there, but it sure does make things easier because it means that I can, if I don't remember that that SR0 is the optical file, if I just send something to CD-ROM, then that's probably going to be fine. Now, if you go look on page 206 to 207, there's a table that the textbook has that has a list of sort of all the common device files that you would expect to find in the /dev directory. All right. Now, I'm not going to read all of these to you. There are quite a few of them, but I want you to go look through that. And one of the things that you're going to notice is that it'll typically describe a device file as either a block or a character device. Let's talk about what that means. So, when Linux is interacting with files in this way, it would make sense either for it to read one character at a time, if it was a certain type of device, or big chunks of data at a time. So if I plug in, say, a keyboard to my Linux box, that's going to be a character device because as I'm typing in that information into the keyboard and it's going into the computer, that's being read one character at a time. You know, if I type a word, I can't really type fast from the computer's perspective. There's a whole lot of CPU cycles in between each letter that I type. So it's gonna think of data as coming in, even if I type really fast from my perspective, that's going to be coming in a character at a time. So a character device is something that's designed to read just one character at a time. Keyboards and mice are kind of the easiest example to think of this. If you are doing anything with serial ports, those are typically the same way. Now, if you imagine that we were trying to do something like this, we were trying to write data to, say, an entire hard drive, we probably don't want to treat that as if it's a character or a character device, right? Because what we're trying to do when we read and write hardware or data on hard drives is to get as much of this stuff done as quickly as possible. And if I'm reading data off of a hard drive at the same rate that I was typing it into a keyboard, it's going to take a really long time to copy anything off of a hard drive, right? So when Linux is trying to do something like that, it's using what are referred to as block devices. Now, block devices are going to be when it looks at a whole big block of data and copies it over kind of in larger chunks, if that makes sense. Now, that's generally going to be a whole lot faster, but for obvious reasons, that's not going to work with a keyboard. I can't read blocks of information off of a keyboard if it because it's thinking in much larger chunks than phrases that I would type. If it's waiting till I have a couple thousand characters before it actually sends anything to the computer, before it writes anything, it's not going to be a very efficient keyboard. As soon as I hit any key, I want it to show up on the Linux box, right? So that's the difference between a character device and a block device. The table that shows up at the beginning of the chapter lists all of that information. Um, and which one is a block device and which one is a character device. But what I want you to see is if you do a long listing of your dev directory here, you can see that what we've got is this will actually tell you what each sort of thing is. So if you see something like this that starts with a C, that's going to tell you that it's a character device. Okay. If you see something that starts with a D, we've talked about that before. That's not a character device and that's not a block device. That's a directory, right? Something starts with an L, that's going to be a link, right? So that's all stuff that we've talked about. If you're expecting to see a character device, it's going to be a C, and if you're going to see a block device, you would expect to see a B. I don't see any block device. Here we go. So there's a couple of block devices. SDA is typically the first hard drive that you see in a Linux machine. SDB would be the second one. If you have different partitions on SDA, it looks like we have two of them on this one. SDA1 is the first partition, SDA2 is the second partition, and SDA refers to the entire hard drive itself. Since all of these are hard drives, it makes sense to think of them as block devices, and sure enough, the system does. You see B's that start with each one of those. All right. So that's the thing that I want you guys to know about the dev directory and block and character devices. Okay, so just a couple other things to talk about in the device directory here, and that is, if we're going to go ahead and do a long listing here again, you'll notice that we've got the normal things that we expect to see when we're listing out files, and then every device file in here has a set of numbers here. Now, it doesn't look like something that's a directory necessarily has two numbers, but everything that's a device file, if it's a character or it's a block device, it's going to have two numbers after it. So what are those things? Those are referred to as what Linux calls the major and the minor numbers. The first one is going to be the major number. The second one is the minor number. And what they signify here, let's go actually find SDA again. So let's take a look at these ones. The first thing here is going to refer to the device driver number that's being used in the Linux kernel. Now, if you're looking at this and yours does not, your SDA doesn't say 8, that's fine. If it does, that's fine too. These things are not guaranteed to be consistent from system to system depending on how the hardware acts when Linux is set up. But what you're going to expect to see is if you have a whole bunch of things that are of the same type, like if they're the same type of hard drive or the same terminal file, or if for some reason you have multiple keyboards attached, anything where it's going to be sort of the exact same hardware. From a standpoint of the drivers that you would expect the Linux kernel would need to make it go, then it's going to have that same number. So it's okay if those numbers are the same. This thing right here, the minor number, the 012, and if we're looking at SDA, specifies the actual thing that is. So if I have an 80, that refers to a particular iteration of a particular device driver. I would not expect to have another 80 on the system, although I might have, say, a 90 or a 50. Okay, I wouldn't expect to have. So you can have duplicates between the major numbers if you have sort of multiple iterations of a particular kind of hardware, and then each one of those is going to be numbered starting with 0. So I would expect to have quite a few different zeros or ones on the system as well, but I'm not going to have the same thing in like the same, like I'm not going to get another, I may have another 8 something, or I may have another something 0, but I'm not going to have another 80 if 80 points to SDA. Okay, that part is going to be unique. Oh, hang on, where did we go? There we go. That's what those numbers signify. Linux also has a really interesting command in here called mknod. Typically, this is pronounced make nod, and this can recreate a device file. But if this is something that you're going to need to know, what you would need to tell it is mknod, and then you're going to give it the thing that you're actually recreating, and then you're going to give it, if it's a block device, you would give it a B here, and then you would give it its major number and its minor number, something like this, right? Now, I'm not going to hit enter right here, and I would encourage you not to do this if you're following along on your VM, because I just made that up. That's not something that actually exists. This is not, SDB wouldn't exist unless I put a second hard drive in this machine. We're going to do that later in this chapter, but right now, that's not something that we would do. So why is this command here? Well, normally when we've created commands on Linux before, we've just used touch, or if you say vi and then you give it a new file name, or if you're in a text editor and you say new file, you can create a new file that way. But for this, that creates a text file. The mknod command is something that allows you to create another block device. All right. Well, um, if you're thinking about how this is, if you accidentally deleted a block device, you might need to use mknod make nod to get it back. Well, uh, so if I erased it though, how do I know what the major and the minor numbers are, right? Well, there's actually a file here, and I'm gonna cat this out. Actually, not gonna cat it out. I'm gonna less it so I can scroll through it. And what this does is this just has a list of all the devices that Linux knows about, and their major numbers. So there you go. That's how that works. Now, um, the other thing you can do if you want sort of more information about this is to use a command called lsblk, a list block. And if you give it this with no arguments, it's going to tell you pretty much all the well. For this is all the hard drive related things. Let's actually pull up the man page to to take a look at that. So um, this is this is not going to list all device files. This is just going to list all the block devices. And as far as I know, there's not a corresponding command that lists all the character devices. There might be, but I don't know what it is. But what this is going to do is this is going to tell you if we have multiple hard drives, each one here will show up like this, and then anything that's a partition on that drive will show up like this. So you can see what I've got here on this system right now as I have SDA, which is just my main hard drive, and then SR0, which is my CD-ROM drive. All right, so That's kind of just a little bit of an introduction to the way block files work. We're going to be doing a little bit of this chapter backwards now because I don't think it necessarily presents things in a way that makes a lot of sense to me. What we're going to talk about is how to go ahead and get to files if we're in a GUI, because I think that's the easiest way to see what's going on. And then what we're going to do is talk about how to mount files and get an additional block device to show up in the system if we don't have a GUI. So what we want to know kind of in the next one is, let's say we actually put a CD-ROM inside the CD-ROM drive. What happens? How do we get to it? Well, we'll talk about that in just a bit.